A slope field is the graphical representation of all possible solutions to a differential equation. In this way, a slope field is very much like a graphical antiderivative. It's very important to remember that functions are solutions to both differential equations and antiderivatives. Since a slope field is only a graphical representation of a differential equation, it should never be considered a proof of anything specific about the function in question or its derivative.
Consider the differential equation dy dx equals 3 minus y times cosine of x. Let y equal f of x be the particular solution to the differential equation with the initial condition f of 0 equals 1. The function f is defined for all real numbers.
Part A reads, a portion of the slope field of the differential equation is given below. Sketch the solution curve through the point 0, 1. So we're asked to sketch the solution curve through the point 0, 1. So first we'll plot that point. Then we can continue the line on either side of the graph, and the key to the slope field is that you don't want to touch the lines because it's a guide as to where you're supposed to go. So you can just elongate the line since the function stipulates that it's all defined by all real numbers. So then you can do the same thing on this side as well and just continue to sketch the graph.
In part B, they ask you to write an equation for the tangent line to the solution in part A at the point 0, 1. So anytime you're trying to find an equation, the formula for that is y minus y sub 1 equals the slope of the equation times x minus x sub 1. In this case, dy dx is equal to 3 minus y times the cos of x, so that would be m. You have to plug in the point 0, 1 in the equation, so it would be 3 minus 1 times cos of 0, and that would be equal to 2. So therefore the equation would be y minus 1 is equal to 2 times x minus 0, giving you the equation y is equal to 2x plus 1. In order to approximate 0.2, you would plug that into the equation for y. F of 0.2 is equal to 2 times 0.2 plus 1. Therefore, f of 0.2 is equal to 1.4.
So part C asks you to find the particular solution to the differential equation with the initial condition of f of 0 is equal to 1. So the first thing you want to do is write what they've given you, which is slope is equal to 3 minus y times the cosine of x. So the first thing you do is separate the variables. You can do this by cross multiplication. So you end up with dy is equal to 3 minus y times the cosine of x dx. And then you can divide both sides by your 3 minus y. Now you have this equation, so what you want to do is you want to integrate both sides. When you integrate both sides, you get negative ln of 3 minus y is equal to the sine of x plus c. Now you are given the point 0, 1, so you want to plug that into your x and y in order to solve for c. So when you substitute your point into your x and y values, you get negative ln of 3 minus 1 is equal to the sine of 0 plus c. So you get negative ln of 2 is equal to c, and now that is your c value. So you can bring this back up here and plug it into c. So now you have the negative ln of 3 minus y is equal to c to sine of x minus the ln of 2. Now, in order to, I'm going to bring this negative on the other side and divide through by a negative. So that will give me this. Now, in order to free my y value, I'm going to exponentiate both sides. So you get 3 minus y is equal to plus or minus because of your absolute value signs, and then e, and then you can split up the e by this property, and you get e to the negative sine of x times e to the ln of 2. Now this cancels and you can bring your 2 to the front. So 2e to the negative sine of x is equal to 3 minus y. And now you bring your 3 to the other side and you're left with y is equal to 3 minus 2e to the negative sine of x. And the reason that it's positive is because when you plug in 0, you get 1 when the equation is positive.